Hi guys, I'm going to tell you a little bit about parallel coordinates as a tool for multidimensional exploration. This is a data set that has several dimensions, and its multidimensionality may or may not be interesting. Let me just show you a quick example of a data set where this works very well, and then I'll show you I've just got it working with the passenger counts database, so I'll show you a simple workflow that I just developed in the past hour or so for that. So this is parallel coordinates. How this works is all right, let me see if I can face you guys this way. This is parallel coordinates. Every line moving across this chart here is a single food. So this is fungi, cloud ears, dried fungi. Let me find another food that maybe we're more familiar with. Flax seeds is one of these, and chia seeds is the other one. And basically, every moment that they intersect one of these axes is the value of that food. So actually, maybe if I have another one, it's the same data set. So for example, here's salted butter. It has 0.7 grams of sodium per 100 grams of that food. And so it intersects sodium right at this little 0.7 point. And the cool thing is you can add these little range filters to any of these dimensions. So if you're only interested in foods that have high carbohydrates, you can do this. And then foods that have low sugars, 20 grams, 20% sugar may be still a lot, so maybe less than this. And you can inspect here. So it lets you see many dimensions at once compared to a scatter plot or a bar chart. We're only looking at one or two dimensions at a time. And then what I've added is once you've done some of this filtering, you can click this export button, and you'll get a CSV out that you can bring into Excel or something else. And so this is the workflow that I've developed for this data set. Oh, where did I put it? Over here. So this is the passenger counts database. It actually is pretty large. It's a little larger than I've designed parallel coordinates to work with. There's about 500,000 records in that passenger counts file, and I'm sure it's problematic for a lot of you. So I barely have it working just enough for you to get started. So it doesn't look as beautiful as the example I just showed you a moment ago, but there are some things we can learn. We see that it appears to be many, many stop IDs. You see we have 7 days, which you can infer that maybe day is day of the week, and that probably is in the documentation as well. You see we have a lot of the routes, and then I've quickly hacked this together. So when you brush in this one, brushing still works. It'll tell you how many are selected in the title, which is maybe a little weird. But so for the routes, it looks like 460,000 are these numbers 100 and below. And then there's a couple routes up here that, another 51,000 that have these high numbers. So I don't know what that's about. There's this dir dimension, which so I haven't looked at the documentation. I'm just exploring totally visually with this. I have no idea what dir means. Direction. Direction? Well, so I see that the only possible value for this dimension is 0 and 1. There's nothing in between. North and south. Ah, inbound, outbound. I see. Okay, so I would expect them to be about even. So we have 259,000 selected, either inbound or outbound, and 250, yeah, so they're about even.
Is this just one city? Is this one of the cities?
This is San Francisco.
And could you put all three cities on the same, like a different color for each city or something, or how would that work? Or would that...
It will definitely make my whole thing fall over because it's just teetering along as it is. Yeah. You
You
could.
could take an X. I know there's an excerpt. You could just take one. I don't know what makes it so big. Is that there's a long time span? But what's the time frame?
It's just that there's many dimensions, really,
Yeah.
and so you get granularity in each of these dimensions, and that's what causes the file to be very big. If you aggregated it up to some degree, rolled it up by week, for instance, right, you would have 7 times fewer records than you do here. But there are a lot of records. So with this example, so you can get these both on my blocks. This is a tool that the D3 community uses to share little code snippets. So I've put 2 code snippets here. One is oh, and let me just show you, I added just that export functionality. So once you've subsetted it down, you can click export data, and it will create a CSV that you can bring back into some other workflow. And let me know if there are any formatting things in that CSV. I didn't test it super well, but it should be okay. So that one is this parallel coordinates export. I also have this super simple one, which is just enough to get it in. In here, I just have the excerpt as the example data set because I didn't want to put like a 70 megabyte file on this demo site. This is the whole code for this example page. It's not very long, and the reason is it's just using my parallel coordinates library. So there's documentation. There's documentation here. You can see actually in the code. The documentation is just at this address. And if you click fork me, well, there's examples of coloring down here. So you can either put a static color is actually what's happening in these examples, or you can give a color function. So I believe in this example, you can pass a function in. So you could just assign a color to each of the 3 cities. And if you construct one big table that has all the data for all 3 cities, you just need a little map that says San Francisco blue, Zurich red, Greenwich green, not Greenwich. What is the other one? Geneva. Hey, so we're just talking about coloring, putting all of the cities into one massive data set, which I don't even know is going to load, but maybe if your computer is a little faster than mine, it will work. And coloring by city, which I don't know how that's going to work, but I'm curious because it would be cool to see all the data sets all on top of each other.
Did you have to, so as far as binding to your data, it's not just a matter of pointing to that file, you actually have to change how do you change all the keys? You have to go into your file and change all the keys, it's the data keys.
Can you repeat the question?
Oh, so he's asking if you want to be using a different file instead of, where's the example there? So this one on here, I'm just using the excerpt for the passenger count data set.
Show us an example of where you're actually hooking into a specific data point.
That all happens internally in here. Inside my parallel coordinates library, there's just a little kind of naive type detection that happens. So it's just going through the first row of data, is seeing in the first row of data, which of those columns are numbers. And it's only plotting those columns because I haven't added automatic support for categorical data yet. That is something I think I may work on later today if I get around to it, but I want to try to help you guys.
It won't display an alphabetic key
No,
automatically?
if there's string data, it'll just throw it out of the chart, but it will still show up in the export. So right now this will only let you plot the quantitative dimensions. Maybe if I can get it working later today. If you really want to be seeing the categorical dimensions in this, there is a way to kind of hack it together. Just by basically finding all the unique categories and then assigning a number to each one. So if that made sense to you, you can go ahead and do it.
Is that a separate file or is that in your core file?
So there is an example of that, and we'll go to another. If you click this ordinal dimension here, there's some example code in there. It's just a little JavaScript snippet that happens right before you load the data into parallel coordinates. And then once you've assigned it to a number, my little type detection thing will pick it up and plot it.
What you're saying, that one in this discussion, that's an interesting idea. You're saying that there could be a generalized feature that just takes all keys and converts it into a category heading.
Yeah.
It takes all string keys in the JSON, converts it into a category heading, so we're just kind of spilling the data out.
Yeah, and there's actually a whole blog post right here by this guy who makes a parallel lines one that actually explains how to set up exactly that detection, and then you may still get the brushing working so that you can do the interaction. So I just haven't included this in my library yet, but I do plan to. Yeah, so that's all I have for you guys. It's just kind of a basic workflow just to get started. So you'll be seeing at least the whole data set and the range of values and some of the relationships between dimensions, and have a tool just for subsetting the data. So that maybe you can get it down. Maybe you can focus on a particular route if you would like. You could kind of filter down to a single one. Well, it's not super convenient. I don't have a way for you just to select a single route, but it looks like we only have 514 here. And
email that stuff to the Google group?
Yeah, and the easiest way to get to it is this blocks/syntagmatic is these first two links. There's a dot right there. But yeah, I'll email that out as soon as they get the address from me.
Are you going to email the link to the blog next week?
Yeah, I'll do that too. And actually, someone also made an example of, I think right here, of actually putting ordinal dimensions directly into the same chart type that I use. So here, it's actually off to the side. Oh, here, there's some letters over here. Yeah, I can send these examples out as well. Any other questions for this general technique if anyone's interested in using it? I can also come around and help you out individually too. It's kind of tricky, but may help you get started.
So the fact that left-hand scale has specific...
It's kind of cut off right here, but...
Just the fact that everything's specific there, that's what you refer to as hacked. That's a specific project.
In this one, actually, this is actually kind of the final solution that I plan on using for.
Is it possible to take that and to see the representation of how the keys are called out of the data set?
How the keys are called out of the
I
data.
always say key. I mean, those are specific. Those each have to be either has to be generalized, that it just says give me the key, give me the category name, and then you have to display the data, or else it has to ask for the key by a specific, the category name by some sort of specific string.
This would be, for example, the stop name would fall under this category of
So your
categorical dimensions.
Is asking for each one of those specifically, or is it generic?
Okay, so right now I'm throwing out the stop name in the chart because the stop name is all a string, and so I don't have parallel coordinates really is like a geometric technique, and so it is really for quantitative dimensions, and the plotting ordinal dimensions on there works, but it's it just takes a little extra step to put it to some numbers.
It will be automatic once he does that.
Once I haven't not yet implemented this automaticness into it yet.
How about those? I guess what I'm asking is how about the category names up at the top of each of the scales?
Yes. Those are just the. Can you hold this? Let me see. Passenger. Yeah. So those titles are just the first row of the CSV. So if you want to change them, just go into the CSV and change the column names. Yeah, I don't have any way of aliasing those right now to say that vino should be vehicle number.
So something I would see that, if I look at your code, I'd see how it reads that first column, that first row, and displays that as a category.
Yeah, that's all. Yeah, it just uses basically d3.keys of the first row, and yeah, just pulls them all out. And that's how it does it.
But is it only that specific project that would work that way?
Any CSV, it will try to do that. So
But which visualization? I mean, it's not the CSV. I know it'll work with any CSV, but which D3 file, which JavaScript file is capable of doing that?
Of importing. Okay, so I do have a really old example that I want to update. I lost.
Several of those would do it, I guess.
Yeah, if you take any of those, if you take any of these examples that's working, you can plug your CSV in. Like that.
Yeah, I would use one of these two that I just created in the past hour. This is the super. Sometimes when you load this, it doesn't work. This is the super simplest one. So this is like the absolute simplest example that I could come up with.
And if you want to have 3 cities and 3 different, you have 3 different data files, and you can, your visualization, your JavaScript file can in fact work with 3 separate data files on the same visualization.
Yeah, what you would want to do is just kind of nest this d3.csv call and load all 3 of the files and then concatenate them into one big array. And then, yeah. And that's not too hard. I can try to do an example of that. I just have to see if they're all the same format and stuff. I haven't looked into that.
Because D3 generally only wants to work with one data file per JavaScript file?
No, let's get into it afterwards. Yeah. Okay, cool. All right, thanks, guys.
What I want to show is just a quick way of deciding which visualization is the best for you, because I think the first part for you all seems to be getting the data into the right format, trying to see what's in it. That's not very easy because the data set is huge, so it cannot even load in Excel, so you have to be hands-on with D3 or Python or something else to be able to see something in it. So I think the next step when you are able to get to grab the data is to try to figure out what is the easiest way to figure out what is the distribution of the data, what you are trying to see in it. Is it a trend, a comparison? Is it the distribution? So I just want to see like what is the. Oh yeah, okay. Oh yeah. Yeah. I will repeat all of this now. So when you grab your data, the first thing you want is to be able to choose the right visualization to be able to have an idea of what's in it, and also of what you want to see. Do you want to see a trend? Do you want to see the distribution? Do you want to compare stuff? There is a visualization for each different analytic task you would want. Sometimes you want to have like multiple different type of visualizations for each task. Sometimes you want a big visualization to try to see all at the same time. But so what I can do now is just to give you an overview of what's possible with D3, how to choose the right type of visualization. And I think the challenge is when you grab your data, trying to find the easiest way to give a shape to this data. And then find an analytic task, like do you want to compare the cities or do you want to see through different dimensions? Do you need to bake in some more data? So that will be the next step, and then choosing the right visualization will be very important. Here is a gallery that I made with some people from the D3 community. There are already more than 1,000 entries in it, so I think that's a good way to start just by looking at images. Like maybe you want to have these kind of widgets everywhere, but I don't think so. Yeah, so here you can you can click on visualize, and if you already know you want a scatter plot, just choose a scatter plot, and you will have all that I had the time to tag as a scatter plot. If you want to go see the exact the database I use, because you can go directly to the Google spreadsheet. Let's see. So that could be a good way to see all the D3 examples at the same time. Okay, so the URL is key equals 0 a q m e. No. So the best way to go is to go through the UI. They will all be listed there. So like this is more than 1,000 D3 examples. So just go through all of them and choose the one that seems to you to be the simplest. In the dataset right now, you have some geo stuff, and it's in topo.json and GeoJSON. We are not all very familiar with this. So just look at the examples. There are some very simple examples that you can just copy paste or fork, because they are mostly on gifts or a tributary or a JS fiddle. So you can copy them and try to fit your own data into it. Yeah.
How many files are involved with doing a map? There's topo.json itself. Is that library a requirement?
Yeah. So the topo.json we can. So that's a good use case. So let's see. Sometimes it's in the tag topo.json. So I have one here, for example. Let's open it. So there are a lot of examples that are on blocks. Blocks is just a viewer for a GIST. GIST is a code snippet manager maintained by GitHub. So that's just a way to share examples, and blocks is a way to see it. You have the code here. So that's the only code you need to be able to see something in your topo.json. So
so everything you need is in one file. You don't need a topo.json library and then the specifics about your...
here, the topo.json library is loaded directly from the from the source. So there is the D3 library. The topo.json is kind of an extension for GeoJSON for very optimized files, because GeoJSON can be very big, but you don't need to be as big. So topo.json is very much more optimized. Then here they also load the jQuery from the CDN sources. But then you just have your typical D3. You can change the projection, and you can find a lot of different projections on the gallery. Here it's called Albers USA, so that's probably not the ones you want, because that's a custom one that is tailor-made for the US, especially because Alaska can seem very big in some projections. So probably you will want to change this projection and choose another one. You have plenty of them. One way of finding them is to go by author and to click on Jason Davis, because he is the big master of geography in the D3 crowd. Mike Bostock also has a lot of examples. So when you want to choose the right projection, you can just go there and let's just scroll and scroll and scroll. So here you are more into geo stuff. And the projections are here. So the Robinson, Wagner, Hammer, sinusoidal, you have a lot of them. Okay, so here you can choose the right projection you want. You can scale it. And then that's the typical D3 stuff. So you select the container, you append an SVG, and then it's time to load your JSON. This one is the United States, but yours will be so in the data set that is involved right now. The tricky part is always, okay, I have an example, I'm able to understand how to put my own data, but then you have to find the right keys. So the difficulty, the challenge in SD3 is a lot into like trying to replicate what you see, but with your own data set. So that's the part that will be the most maybe tricky, is to find the right key to be able to see the right thing.
But that will correspond to keys in
the topo.json file, yeah. So, but that's something we can work on individually.
What about, is there something called frames or tiles? How does topo.json know that you only want to look at one city?
Topo.json, like GeoJSON, works with features. So you have a list of features, and a feature can be just a continent, can be a city. So it just depends on what's in it. But a shape is called a feature. You can also have shapes like points. Like you will have roots in your data set. So that's why you have to tweak this part to get the right information. And then it's just a matter of appending a path, and the clever GeoJSON plugin will just like give you the right path. So that's just an example. Like you find what you want. So it can be a map. You go to the gallery and you try to find the simplest example you have, and then you try to put your data into it. And if it doesn't work, you try to find another one to see if it's simpler. So I think that's one of the workflow that you can use. I just want to show a second thing, and it's that what I use personally is kind of an Excel for big data, but that's a bit obvious because that's a company where I work on. So when I'm not able to open it in Excel, I open it in Datamir. So a workbook is exactly like what's in Excel. So if you have a data file that is too big, you can come and see me, and you can have a glimpse of it. So it can just help like to see a bit like what's in it before you try to find the right visualization. So what I do with this is I just go in an interface where I can, for example, drop an area chart, and then I go to find my data. That's the same data set that was in the spreadsheet that I have here. I can take like the trip ID as labels, and then I can just drop some data everywhere.
What is this that you're using?
This tool is called Datamir, so that's the company where I work, and we developed this thing in D3. There is a free personal version, there is an academic version that is free too, and there is a professional version that is crazy expensive. So, but yeah. So, just to give an example, the first thing I would choose is a scatter plot or a line chart. The line charts it's exactly the same thing as a bar chart, as you know, but it's better when you have time, because the lines goes to because it's a continuous axis. So when you have a continuous dimensions like time, it makes more sense to have an area chart. Since we have multiple data, that's a stacked area chart. So I can drop multiple data columns here. And then I can try to clean it up to see what's in, to change the scale, to see if I can see something else in it. Maybe change the line tension to see if I have some peaks. Okay, so that's the kind of thing you can do with D3. So when you don't use this kind of UI, that's still what I would start with D3. I have a data set. If I have time in it, I will grab a line chart. So I will go in the gallery and I will just copy paste a line chart code. If I have some categorical data, it will be in a bar chart. If I have multiple dimension for the same categories, I will take a stack bar chart. So, so just try to find the thing you are the most comfortable with in D3. The last thing I want to talk about is like you always have an analytics task when you choose a visualization. So do you want to see the distribution? Like, is there like a big tail, or is this a curve, or that's what you want to see, to have an overview of the data. But sometimes what you want is to compare data. For example, in this data set, it can be I want to compare San Francisco for like the delay time versus Geneva, and so the scatter plot is the best one to compare two things, because you can just map one on the x-axis and one on the y. But if you want to compare three things, you can have multiple scatter plots. You can have parallel coordinates. What I prefer is to have multiple things, because then you can see that this dimension is not interesting to compare. So I think a small multiples is always the best way to start. Like a bunch of bar charts, I think you can have a whole dashboard just made of bar chart, and you can understand a lot of things in your data. There are a lot of examples of bar chart on the gallery, and that's one of the easiest thing to do with D3. You can have time on bar chart. It's more typically in line charts, but it's okay too. So the only time where I will want to go with more weird visualizations, for example, maps will not go into a bar chart, so that's just obvious. Parallel coordinates when you have a lot of dimensions and you want to compare them all. Then I would stay without the dimensions that are maybe just made of squares, because people tend to go directly to more trendy visualizations like this. But all the radial visualizations has the same thing also in a Cartesian space, and that are often better at seeing things. This one is called the chord diagrams, and it's mostly a network. So that's for graph data that we don't have in this data set.
Totally graph data.
Yeah?
What? Connections between stops? It's like going source stop, destination stop.
You're right, in fact. There is a very good example of this.
Oh, it's a Uber. There's an Uber cab chord demo. Yeah.
You're right.
Everything is graph data if you think about it.
In some way, yeah. So that's one good example of inspiration that you can grab from the gallery. Like here, it's just rides. It's taxi rides. So yeah, so Kai said that there is a lot of network data into it, because you have a start and you have an end, and that's the case here. Like, so the cabs that will start from financial districts and stop at the South of Market. You see, so. But this is the same thing as an arc diagram, by the way. There is not a lot of example about arcs, but this is one. It takes time to load.
Hey, can I steal back from you when you're done? I have.
Yeah. Yeah, so here you can see that when you click on visualization, you have a lot of different things, and you can choose the best one you want. So scatter plot for comparisons, Parallel coordinates when you have a lot of dimensions that you want to compare. Tree when you really have trees in your data. The chord diagram is a network too. The pie chart is only for when you have a percentage data. It's totally useless when you don't. Histogram is when you want to bucket things, so that's like a bar chart, but where you prepare your data into buckets. This Sankey diagram is for flow diagrams. And you will maybe have to use the choropleth is also a map, but with coloring. So that's a thing that you will want to see probably in this particular challenge. So yeah, so you can just have a look at this to have inspiration. That's it.
Thank you.
So it's going to come back to me. I have a really sweet example of small multiples, and I pulled this Zurich data set into parallel coordinates as well, and I see some challenges that you guys will be facing. So this is something that I did for, is this working still?
Yeah, you have to be very close.
Closer and speak up.
Okay, even closer. This is something that I did for the Bureau of Labor Statistics, just to explore this data. And this is what small multiples maybe could look like. There's simple little spark charts. And all I did was put them, and then when you hover over, you can see that this is gasoline from the Midwest, and this is automotive diesel fuel from the Northeast. And if we scroll down, we can, I think there's several thousand prices that the Bureau of Labor Statistics collects monthly. So each pixel here is actually 1 month of data. So as it goes across, it's 1 month. These are Thompson seedless grapes from Midwest urban areas from 1980 to 2012. Yeah, and as you can see, once you plot a bunch of spark charts, you can see patterns, and these patterns are just the data, right? It's nothing. It's simply the quantitative data and the shape that it makes, and you can. Humans are so good at just quickly recognizing patterns. I highly recommend using small multiples, maybe to compare stops, or to compare bus routes, or something like this, some quantitative variable that's changing over time for that particular entity, and then plot it for everyone and just have a huge table of charts. Looks very good. And lets you really explore the data quite quickly and get a sense of what is the dynamic going on. The other thing here is I plotted the Zurich data set. I plotted Zurich next to San Francisco, and one of the things I noticed is that at first the dimension names are not the same. Let me just rotate. Let me just rotate these. The dimension names are not the same, so that's going to be slightly challenging. And they seem to be having. There's many different metrics that are actually being calculated in the Zurich data set. I also didn't see a passenger count data set for Geneva. So this is a really big challenge that I was thinking about. Whenever you take data from a totally different entity, data from the United States and France, or data from the World Bank and someone else who collects Kickstarter, right? You have different mental models of what is going on and how the system works. In many cases, there are things that are the same. Like you see that San Francisco has a stop ID, and also Zurich has a stop ID. But if San Francisco and Zurich if two stops have the same stop ID, it doesn't really mean anything. For something, if San Francisco if you're 5454 and Zurich you're 5454, that's a coincidence. I don't know if it's necessarily meaningful.
But it's still a common key that you can use to start the comparison.
Yeah, but it may be more passengers loaded. It's still going to be some quantity of humans, so maybe that's meaningful. Dates maybe are going to be, they may be in a different format, but we generally still use we have the same concept of time generally. But there is, It is challenging.
Much more precise in Switzerland.
It's better in Zurich. Yeah, the formats are going to be different, and so there's going to be a lot of just data challenges when you're merging data sets like this, and that's why I couldn't just put it on the same plot. I had to make 2 separate plots, and yeah, so it's a pretty challenging thing. I don't have any quick answers for you guys.
It seems to me that the elephant in the room is domain expertise, domain knowledge. I mean, to really know. I mean, it's true. It's like chicken and the egg thing. It's like, how do I know what I'm looking for until I look at the data? I think you're talking about that a lot. Like, well, examining the data, what does the data tell you? But you do need, at some point, domain knowledge to really know what those interesting points are. I mean, you might not see something that's apparent if you weren't really aware of the vocabulary of that domain. What the implications were. I mean, that's not really necessarily the topic here, but
Has anyone here done the work of merging these data sets from multiple cities? Someone over there.
Yeah, I don't know. I mean, you mean for this particular project or in
For this particular project, yes.
No. But in general,
I think that actually would be a useful topic. I mean, I don't know if you're cooking up right now, but it seems like that is really particularly quantifying for this project, is how to take disparate sets with disparate categorizations and draw. I mean, it's maybe difficult or challenging enough to look at one complex data set and see stories. But the technical difficulty, or just the normalization and how to take domains that don't fit together, but yet do. I mean, we're searching for meaning. There is meaning that we're looking for, but it's hard to define. I don't know what that's what I think. That's why I think.
I mean, this is a problem in many domains. Like if you just take a look at healthcare in the United States and you take a look at healthcare data, I mean, this is a problem across hospitals. They don't have the same way of representing their data on patients. So when you go to a different hospital, this challenge that we're seeing right here, this is just kind of like a microcosm of this huge, broader challenge with data that is, going to continue to be a challenge for a long, long time.
even within the same company, it's a problem.
Even within the same company.
Yeah, you could spend more of your time messing with the data, plotting it, or thinking about it, or modeling it, color cleaning, what you're talking about is always an issue. But it would be nice, one thing about it is you only need to do it once. So it'd be nice if somehow we could all get together and maybe do it once on this data set. Maybe we want to do it different ways, but a lot of this stuff is usually pretty straightforward data cleaning.
Yeah, once you do it, put it on GitHub so that I've done a little bit of this with Bureau of Labor Statistics and USCA, but yeah, put it on GitHub because it's so challenging to get there, and I feel like once you get there, you're so exhausted from cleaning the data that maybe you don't have the creativity to explore, and you want to just put it in the hands of other people so that they can explore it and push it even further and take your work and expand it.
Has someone already done it around here? You said.
All right, so what I want to do now is take you guys through a little bit of my prototyping process, and I sent out a link to the routes data for San Francisco and Geneva. Apparently Zurich, the route data is in a different projection, so we'll have to run a script over that, and again, data problems, but for now what I want to do though is show you guys a little bit of the various tools available in D3, and also how at least I go about thinking and figuring out which ones I'm going to apply and debugging as I go along. So I want to do this in sort of a freestyle fashion. So if anyone can drop a beat real quick, I'll wrap. No, I'm just kidding. But I will I will be coding this and explaining as I go. We'll see how I can do that if I can do that with one hand or not. But to give a little context, what we're looking at is this is tributary, and what it allows us to do is write JavaScript here. In the current configuration, it gives us an SVG on the left. So D3 is a JavaScript library, right? You saw all the stuff it can do. One of the main ways that people use it is to render SVG graphics from their code, right, with the data, or using the data. And SVG, just real quick, is a lot like HTML. It's DOM nodes, like the tags, right, XML. And if you give them certain properties, they will display differently. So all these lines are path elements. And so that's a general way we can write, draw.
Can you zoom in?
Zoom in. Oh, yeah. Whoa, why did it do that?
That looks great.
Cool. So what we have here is that these lines, we can give them a stroke color. So I'm just going to cut this out, and if I just say, this uses CSS stuff.
Hey Ian, can I back you up a little bit?
Yeah.
Is
Before you
this
go into the
D3?
coloring?
Yep.
Yeah.
So let's say I pull up this tributary, and instead of, I guess my first question would be, how did you get or develop routes.json?
Okay.
JSON format out of the CSV beast that.
So routes.json is actually already a JSON file. There is a geo folder. Let me do this.
Was that in the GitHub?
Yeah, so if you go into public transportation, San Francisco, in this geo folder, there's a geo.json file, and there's routes and stops. And so what I'm going to do is show you, I'm going to take the stops, and we're going to plot them on the map, and using SVG shapes, and we'll put them on top of the routes, and we'll try to do, just go through that process, and I hope that you understand. That would be awesome. So yeah, so we'll go from a plain geo.json file, put it in tributary, plot it on a map, try to understand projections, what's going on there, just basic SVG manipulation with D3. And yeah, so I guess a couple of basics about tributary is that you have a JavaScript file, you can add more files. I made a routes.json, there's a style sheet so you can style stuff, which I was using to style the countries here, and I'll kind of show you, like, whoa.
Inverting it, sucker.
Yeah, don't want to do that. So this is like the world plotted in Mercator, and so the style sheet was styling the countries here. For the example here, I just deleted the world. We don't need it, right? So let's add the stops. So I'm just making this new file. I'm going to use Linux stuff. Don't worry about that. But basically, you just copying the contents of that file. I guess I could do it a normal way. I'm going to select all, copy, paste it in here, and
Oh, that's what you're doing in each case, pasting code right
yeah,
into the tributary?
exactly. And so you can do this if you see other D3 things or SVG stuff and you want to try it and play with it in tributary. That's how I generally use it. I see, oh, that's a cool effect. How do they do that? And I try to set something up and play with it until I get it. So, and the only other thing that you need to know is that you can just select the SVG element that's on the page. It's given to you already. So you don't need to set up a index.html. You don't have to include D3. It's all there for you. And the rest of this, you could just literally copy paste this into your own index.html file or wherever, and it would run just the same.
But TopoJSON's not part of this. Is it embedded? Is it
Stops.
is it being called internally?
Don't you need to get this?
Oh, yeah. So I haven't started that. So TopoJSON, you can add just URLs.
Either one, I guess.
I'm sorry. So GeoJSON is just a standard, right?
It's an API that's being called from some of these files, no?
Oh, sorry. Yeah. So the magic that's happening here is if we say stops, is tributary is setting this up for us. The normal way to do this would be a d3.json, path to stops.json, and then you do all that. But I set it up here so that you don't have to like nest your requests and all that. So any JSON file you name here becomes a variable on tributary. So yeah, so this is sort of like magic that tributary does for you. So really, these first 3 lines are the magic. Well, I guess this too. And then yeah, the rest of this is just straight up D3. Okay, so and then sort of part of my process too, though, is not believing anything, even if I see it. So I always console.log everything I do, and I suggest you do the same. So I expected stops to be an array. It wasn't. It's actually an object. It has an array of features, and each one of these is an object that has a geometry and properties, apparently. The geometry is coordinates, so that's a latitude, longitude coordinate, right? And it's a type point. And there's certain properties. So we can see the street, the Rakastapa, whatever that is. It has a shelter, I guess. Stop ID, name. So these are the kind of things that we might use when we want to do tooltips, or if we want to color by, is there a route on here? Does anyone see a? We might have to join with part of the other data set to find out the route that this stop belongs to.
The routes have stop ID? No.
I think in the CSVs.
Routes and stops routes have multiple stops.
Right, right. So if we want to know this stop, what route it belongs to, we might be able to find that out.
It should also have multiple routes.
From routes. Oh, it could. Yeah, it could have multiple routes. Yeah, so we won't join on that. All right, so let's start with the stops, though. So we see the structure of it, right? So that's the first thing you always have to figure out is, what does my data look like? And what we ultimately want to do is plot, like what we want to do right now is plot a circle for every stop. Let's just start with that, right? We won't worry about color or anything like that. And to do that, for each circle, we'll need one of these geometry coordinates. And then we need to take the coordinate that's in lat long and turn it into XY pixel coordinates. And to do that, we use a D3 projection. And I think, Chris, you mentioned about all the projections that are available and all those examples in the blocks. You could just switch any of those out here, and it would look different. Oh, I guess that one doesn't. Another thing is that we're so zoomed in here. Like you saw how far we zoomed in to get to Geneva over here. That like.
Which file is that coming from?
Is what?
The world there. Which file? Oh, world.
There's a world. This is a topo.json file that I took from one of Mike Bostock's blocks examples. So I mean, and that world file is useless at the scale of the city.
And so are we? Is it zooming into? Oh, which city was that? Was that? Geneva?
So this is Geneva. So if we
just
click here or just.
Okay.
Yeah.
You're zooming away.
Yeah. So we're zoomed really far into San Francisco here, and I've actually already there's an example here. This latitude longitude point is, I guess, the center of San Francisco according to Google Maps at least. And so we can sort of as a simple example plot that there, and I believe it's styled. Let's make the opacity. Let's just make it black. Make it bigger. All right. Whoa, that one's. So there's the center of San Francisco being consumed by some large circle.
Wait a minute, I thought we were looking at Geneva. How did we get to San Francisco?
Oh, I'm sorry. I was switching between tabs.
Oh, you were, okay.
I was just showing Geneva because I had the world file and showing you zooming in and out.
Okay.
That the process of getting down to this zoom level was centering the map on San Francisco using this dot center, and then scaling way the hell up or down. I don't know. Scaling up, I think.
And so are you actually using to get your XYs, you actually using the Mercator projection, or are you just translating and dividing because it's so close it's linearized?
Oh no, it's actually using the Mercator projection.
Okay.
And if we were to switch it out to any other one, you would see it. I wonder if...
But the deformation is going to be pretty small on the scale of San Francisco.
Right. And here's an orthographic projection, which is like seeing it as a globe, and here everything's all screwy.
Yeah.
So it's not as... Oh. Yeah. So we'll just use Mercator for simplicity right now. And then I encourage you, though, in your projects to use something other than Mercator, especially as we compare other cities, with cities across the world.
What about shapefiles? Is there TopoJSON shapefiles?
So the geo folder contains GeoJSON, shape, and TopoJSON.
Oh, that's the SHP folder.
Yeah, and so you can also, I think there's a link to at least San Francisco data on the mailing list, and I believe some of the other cities for additional shapefiles. And there's online tools, if you Google for them, you can convert to GeoJSON or TopoJSON.
Could you show us an example of how to actually pull some data from the file that you just added, the stops?
Yes. So that's the next step. So we have stops here, right? And now what we want to do is let's make a circle for every stop. So I'm going to select all circle, and normally I would give it like a class like stop. And so it's stop features. If I remember correctly, yeah, features is the array of stops, right? So
This dot has two meanings. The first one is just saying, so this is a CSS selector, so this is selecting all the circles with class stop, and this is JavaScript. So this is selecting the variable stops and its attribute features. So just because they're right next to each other, it may be a little weird, but it's totally two very different contexts.
right, and I'm not going to get into the mechanics of the enter, update, exit pattern for D3, but that is like the name of a blog post from Mike Bostock, and there's a lot. This is part of the hardest thing to truly understand about D3 is like how this part works, but you can do a lot of cool stuff by just copy pasting these lines and working with this stuff that we'll cover in a second here. And then if you do get stuck, please feel free to reach out or raise your hand. Yeah. All right, so this we want to append a circle.
It's called the general update pattern is the name of the blog post.
Yeah.
And thinking with joins is another good one, both by Mike Bostock.
Okay, and so here I'm going to set the class, because I said I wanted all these circles to be class stop. And the interesting part, it's slowing down because it's like 3,000 stops. We need to provide, the circles all have a radius. So if we do a radius of 10, we see up in the top left corner, there's probably 3,000 circles stacked up here. We haven't told them where to go, but we've created them all, and we've given them a radius of 10. So the way you tell the circle where to put it is through these two properties, cx and cy, which are the x and y coordinates respectively. And if I move 100 around, or change cx, you can see it moving in the x-axis. But of course, we don't want to manually write the numbers in. We want the data to do that for us.
So is that putting like thousands of circles right on top of each other?
Yes, yeah. And so they're actually, all the circles have like 0.6 opacity, but you see it's fully black. So the key here is that this .adder thing is setting attributes for each of the circle elements that we created. And we're giving it an object, so we're setting the R attribute, the CX attribute, the CY attribute. But what we want to do is set it as a function. So we want to, if we look at our data, we take any of these as an example because it will do the same function for all of them, but they'll all have slightly different coordinates, right? Like because none of the stops are in the same place, or I mean maybe some of them are, but. So we want to use this to determine our x and y. So the way you might do that is just return g dot or d dot geometry dot coordinates. I can't type slow. So we're just going to do this. But this is actually wrong, right? Because we are saying, hey, put yourself at like negative 122 or 37, whatever the lat long is. So we need to, now we don't have any circles showing up. Because we need to map from latitude, longitude into our screen space here. And in SVG, x, y starts at the top. So this is 0, 0, and as you go here, x gets bigger, and as you go down here, y gets bigger. So luckily, we already made this projection function, and all we have to do is call it. And we see all our circles go into x. And we have stops.
Can you show us projection again?
Yes. Oops. Whoa.
That's a lot of stops.
Yeah.
That's foggy.
Yeah. This is it. Oh man. Here's fog. But yeah, so okay, so projection.
Oh, it's using scale.
Yeah, so this is essentially, we are telling D3, okay, whenever we give you a latitude, longitude, we want to map it to a 2D, like flat, plane using the Mercator projection. So all these projections are just mathematical functions which take two numbers and give you another two numbers that you can put on a flat piece of paper.
So instead of a domain and a range, in this case, it's using...
Well, yeah, so it's, I mean, domain and range is also from math, right? Like domain is the numbers you put in and the range is the numbers you get out. So this comes from when the world is round, but we want to put it on a flat piece of paper. So how do you cut the globe and stretch it out and flatten it? And that's what these projections are. And depending on the way that you cut and stretch, you get different different deformations. And that's what we're talking about. Albers, is very US centric. The United States looks awesome and the rest of the world looks like crap. So you don't, unless you are looking at the United States, you might want to use Albers, but otherwise, especially since we're comparing with international cities, that wouldn't be really fair, right? So.
But at this scale, the projection doesn't really matter.
Yeah.
Sure. If you use an Albers projection versus a Mercator projection at that scale, it's going to make it.
For this city, if we were looking at Geneva, it would be indecipherable because
But if you've centered on Geneva.
Yeah.
Yeah. Okay, so, it can make a difference, but yeah.
Have a differential geometry battle.
What's
Yeah.
985,375?
A very big number.
So whenever you see something like d3.geopath or d3.geomercator or d3.scale category, all these things basically are setting up a function that just takes and same with the scales. It's exactly like you said. They take an input, like the scale always takes a domain and returns a range. And whenever you're calling these methods on these things, it tends to be what you're doing is you're configuring that function to behave slightly differently.
Are those default values generally?
No, what I've put here are actually the customization that shows us San Francisco.
Yeah, can you play with that?
Yeah, I could. So as I make this smaller, we're going to zoom out a lot and then a lot.
Because it looks kind of like a random number.
Did you do
It is. Yeah, I just did it with a slider. So it is not.
Number that allows you to see it.
It's a zoom.
Exactly.
Right.
He didn't say, how about 6, how about 7? He used a slider. That answers my question. That
Yeah.
It's kind of an arbitrary.
That's what I was trying to show here, is that if we like just, zoom out here, you see the world, right? And then you zoom in, and then you see Geneva.
Using Tributary, how do you pull up the slider?
You just click. It's because I resized it, the position's off, so this is how the slider would work normally.
Can you make the stops smaller? Like it's just a circle with whatever, right?
Yeah, let's do that. So instead of radius 10, see my slider's all the way up here because I zoomed in. They're like, so they're like 4 pixels, yeah. And then I can make the routes thinner by 1. It's just faster to type. And then, let's see. Well, let me turn off this one. So, we could put a stroke back. Oh yeah, this doesn't need quotes.
And then
Small. What else you want?
And so this has been super awesome. We've had lots of fun playing, and now I go off and I change stuff. How do I save it?
Okay.
I can copy and paste it to another file.
Well, so we can actually just, if you can log in with GitHub, or you don't have to log in at all, and it'll just make anonymous GIS. But you click the save or fork button. Clicking the fork button will create a new GIS as a copy, or clicking save will like save over your work. So I just saved over this one because I had already made it. But let's say I wanted to do something like, now I got the stops and I want to go a different direction with this and experiment with connecting the stops together somehow. I would fork it, and the internet's being really slow, so this will probably take a while. And this will basically just create a new URL up here with a new number. So each one of these is backed by a GitHub gist, just like the blocks. And so if you like,
And it goes under your name.
yeah, they changed it, so now it's like on your name. So then you can actually see that the code's all here.
So if I log into GitHub, like how does it recognize that is used?
This is, if you're logged out, it just logs in here and it'll bring you to GitHub with the OAuth type thing, where it says like allow this application to, all it asks for is the ability to post and read your gists.
Tributary is a GitHub.
No, Tributary is a project that I'm working on. It's open source.
But you built in this functionality to save it to the.
Right. Instead of setting up a database and a file system that I have to maintain, I mooch off of GitHub.
Cool.
Yeah. They're very nice about that. Yeah. So I hope this can get you at least somewhat started putting stuff on a map, playing with the properties as part of their data. Let's as one thing add a little tooltip to each of these. So we can do, I think it's the title attribute, right? So remember the data, there was some properties. And so let's look at it again to see which property we want. Just choose a random one. So I think stop name would be a good thing to put on there. So now I think if we hover over, oh, it's so disappointing. So this is what I do when things don't work, is I inspect the DOM inspector. If you're doing JavaScript development and you need to use yeah, so it is here.
But does it work with SVG?
Title is what you use for tooltip?
Yeah, I thought so. And I've used it with SVG before, I'm pretty sure, but or maybe, yeah, maybe it is only HTML stuff.
In fact, the title, it depends on the browser, because in the HTML specification, it's not a tooltip, it's just an attribute. But most browsers will display it as it is, but that's not in the specification.
Oh, it's really slow now. So every time that you type anything in Tributary, it erases everything on the left side and reruns the code. So as you're dealing with bigger data and stuff, it will slow down. But it is kind of a testament to how fast JavaScript has gotten, that it can draw so fast you can't even see it, right?
Every time you say?
No, every time you type any character, it's rerunning everything.
Oh my gosh.
Yeah, it's actually like makes any good computer scientist cringe, but yeah.
Or there's no say. Oh, that's right. You save it. And overwrite.
Oh shit. So I'm not logged in, so if I save right now, it's going to make it anonymously. Eventually. With processing, unfortunately, no. You can use plain canvas, but I'm planning on doing a processing JS version where you could write processing and it would render into canvas. I haven't gotten that far. You can do Canvas, WebGL, or HTML though. So if you're used to the Canvas API, it's not too much harder than processing. I mean, it's not, well, now processing is better.
But you can use a JS fiddle for some kind of the same Tributary is just better because of the style, because of the integration with GIST, and because it's...
Yeah, but at this point, which is really fantastic, like how can I add some animation to like an outline? I don't know what like correlate some of the data to certain animations and make it interactive.
So D3 is really actually powerful for animation. And interaction. So we have access to all the standard browser events. So we can let's do a mouse over thing where whenever we mouse over one of the circles, it'll grow, and when we leave, it will shrink back to its regular size. So that should not be hard at all to do. Let's see. Can you hold this again?
Are you talking about like buses moving through the stops? Or?
Just like, for example, if I wanted to create an interface that I would navigate through time and just seeing like the popularity density depending on the time of day, something like that. So I want to get that information up static, like not
Absolutely.
pulling arbitrary data and like displaying, but make it, pulling, I don't know how you do it, like select some criteria and then create an animation and maybe play, you can see the whole animation.
You can find a lot of
You can find a lot of examples on the gallery, and it's all around the on function. The on function is binding with all events. It can be key binding, mouse over. There is also a brushing feature in D3, so you can have like an axis, and you can it's a bit like a range slider. So yeah, so you can select a range on time, on parallel coordinates. It's on the axis, so that's the brush feature.
Or even in even in the geo projection, there's examples of using the brush, and you can use. Actually, all the projections have an invert function as well, which lets you go from XY space back to latitude, longitude. And so you can use that invert with the brush to be able to select particular dots here and filter the original data. If you wanted to say, you know, I want to see all the stops in the northeast corner, or whatever, and just draw a rectangle.
What is that called?
It's called the brush component, and you need to use I think, invert the projection.
I have a series of tutorial videos, and there's one here on the brush, and there's code example in tributary. And so you would use this to sort of overlay this on your map, let's say, or on your time. But yeah.
There was a really great example on Thursday from Mike Traverse. Can you pull that up?
Blocks or?
And then the meetup.
Oh, yeah.
Yeah, that's a cool idea. A timeline animation that changes all the data according to the time.
Yeah, and that's just a filter. You filter over time, and then you just reselect all the data and redraw the whole thing based on whatever you selected, and then you can pan to see the changes.
Yeah, that's a filter of the data that is already loaded. You just load the data once, you filter it, and then you just update your visualization.
And so the filter function, it runs all the data through it.
All those Republicans.
This is an example someone presented at the meetup on Thursday. And it's a great example of just bidirectional filtering. So you can filter either way, which means you get two ways to subset the data and get a selection. Obviously, it's very hard to select all these states from the map itself, but very easy when you have this view of the data.
Yeah. And so here. If you go to the meetup, it's Mike Travin linked it. We actually videotaped this meetup too, and we'll be uploading it this evening. Yeah, that's why we videotaped it, so you can see it now. And it was about intro to D3. So we had a couple of great speakers, including this guy, helping you out getting started with D3, and then some people presenting their projects. So yeah, and then I made with the events, the on stuff that Chris was talking about. We can now transition these, and all I had to do was say .transition. And it has some nice defaults, and you can change how long that you want the transition to be and the way it behaves, stuff like that. So there's a ton of stuff for that.
To get some more meaningful interactions, you may need to create some intermediate data structures. So for example, maybe if you're hovering over a stop menu, you want to see all the routes that pass through this stop. And the way the data structure currently is, you're going to need to create this data structure where you can look up a list of routes by stop, or perhaps a list of stops by route, just by going through and kind of constructing it.
And are you talking about that you would parse the data set when it's loaded? You do this dynamically and form a secondary data set that you could then access through a function?
Yeah, so this would just be, you can do it all in JavaScript if you want, just a JavaScript data structure. Just go through each one and for example, just say, hey, each for each row, if this stop, if I've seen this stop with this route before, that's fine. If it's new, just add it to this list for this route, and then you can go do it for the stops as well. So you have like because there's a many relationship between the stops and routes. Each route has many stops. Each stop has many routes that pass through it, and that is not given explicitly, I think, in any of the data structures. So you have to construct it yourself.
And you'd want to do that kind of statically. You'd want to form that static data collection. You wouldn't want to try to render it, do the logic that created that static. You would want to do that for each individual data point and go and calculate it.
After you create it, you can save it and not have to calculate it again. That would be, you could do that.
Yeah. For the previous question, like if you wanted to do like animation, that's like a bus, moving on one of these lines, is that the same thing with on?
That might be a little different, but so there's a lot of different ways you could do it. One way is to take advantage of the SVG path and the API that they have, which allows you to get a point along the path. So I have another, actually, part of that, another demo. Is it on this one? I think I have another series. So there's a way that you can like animate a point along the path parametrically. Let me just bring that up. Path. This one. So here, when we click, this line was already drawn as a path, and then I'm using two tricks, one to make the circle go along it, and then another to make the path progressively reveal. And so the code, though, is not, it's only 70 lines, but essentially what I'm doing is is this the circle? You get the point at a given length. So as I'm animating it, I like say, when it's halfway across, I get the point halfway through the line, and I use that to move the circle. So you could have a bus here, a picture of a bus, and then move that along as one way to do that, yeah. Any other questions?
I'm wondering how to make scales, how to scale range of numbers to other range of numbers.
Yeah, sure. So let's do another quick freestyle then. Here, can you hold this? Yeah. All right, so in this tributary, I loaded the excerpts from the three San Francisco data sets. So I have pass count, the real time, and scheduled. So let's just take the passenger count, and I also logged out the first element of each. So I believe this is the pass count. So we have all these fields, and let's see here. Where's the actual count? Load.
The count of what?
Passengers, right? That's what this is.
Yeah. Yeah.
Let me log this. So what we're going to do is we're going to choose a number. We're going to find out the maximum minimum in the data set here. And then we can do a quick bar chart or scatter plot or something and plot those things using that scale, like from the minimum and maximum to like a set of pixels, right? Let's say we want to have our biggest bar be 300 pixels. So we'll go through that. And this is only an excerpt, right? So there's only a few stops in here. Oh, I think it's off and on, right? Oh, do none of these have actual...
I don't know, maybe load is passenger screen, the bus.
Ah, yeah.
Is who steps off and
console window again? Do I have to type in the console?
I see. Let's start with load then. Sorry. Okay. So there's some D3 is more than just drawing and manipulating SVG. You want to get through? Thanks. So we have several other utility functions like minimum and min and max that we can use. So we take our, I called this pass count array PC, and we can go through all the elements of this array and run a function over it, and we return the value that we want to look at. So in this case, we want to look at the minimum and maximum load. So we would say d.load, and then let's log out what the max load is. Now it says 0, and this is weird, right? Because we see 42 here, but oh, min, right? So that's not weird for the reason that I wanted it to be weird. It does actually work in this case, but what we really need to do is, these are strings here, and we need to do these as integers, as numbers. So now when this prints out, it prints it out blue. I don't know if you can see that instead of black, but that means it's an actual number, so we can add and subtract it and do that nice stuff. That's just one thing to be aware of with CSVs in general, is that D3, when you parse a CSV, it doesn't actually know what type your data is, so it just gives everything as a string, and you just have to kind of figure that out. Unless you're using parallel coordinates, and Kai implemented something that tries to figure it out, but it can be wrong. So now we have our minimum and maximum. And so if we want to scale, we basically want to have, like, say, plot all of our stops, right? Each one of these over time, let's say. Is there time here? There's time stop. Yeah, I don't know if there's a date. But you know, we can imagine a scatter plot where we want to have the load, or a bar chart even, the height of the bar be the load, or where the circle is be like the number of passengers, right? So that we can see ones that had a lot of passengers. But then we don't want it to be 42 or 0 to 42. We want it to be like the biggest load is always 300 pixels, right? So let's just go ahead and try that. So I'm going to define a scale. And this is sort of the technical, like the direct answer to your question is we define a domain, which is our data range. So our data goes from, let's say, 0 or min load to max load. And the range we want is 0 to 300, right? So that means that when we use this scale, we'll put in a number between the min and the max, and we'll get out a number between 0 and 300. And this is, it so happens that our minimum load is 0, but you could have it where all your data is above 0, and this would give you like a relative scale. So then to use this, select SVG. I'm gonna make circles just because it's quicker than bars, but it's the same principle. We're gonna pass in the data. We're gonna just pass in the pass count. We're gonna enter and append a circle like last time, and then we're gonna set some attributes. So we can just set the radius to 10 again. CX. Eventually, we might want to make this based on the time, but for now, I'm just gonna return, like, let's say 100 plus I times. So I'm just gonna spread them out evenly. So I is like 0, 1, 2, 3, like you're just counting through them. So each one is gonna be 20 pixels to the left of the last one. Make them a little smaller. So that's not using a scale at all. but just to put them somewhere. And so now, let me move these left. And let's make them a little smaller. All right, so this is where we use this scale. So they're all starting at, right now their y is just at 100 pixels. If we pass in scale and d.load, and I believe this actually, we need to parse this integer. The last several had 42, so they went down to 300 pixels. And we can see that if I just make this 0, and I can change this. My sliders, can I? Right, so the minimum, maximum here. See how these are changing differently, right? Because there's something like 1 or 2 is their value. But yeah. Does that answer your question?
The data doesn't look right. It kind of looks weird.
It's like you're looking at you got a snippet.
Oh yeah, this is just an excerpt, right? So it looks like what happened is that there was nobody on the bus, then they got 2 people, and then like 40 people jumped on, and they stayed on the bus for a while, right? So, yeah, flash mob. Yeah. All right, so I'll fork this one, and I'll send these out to the mailing list. Yeah.
Cool.
Yeah. More questions?
And you were talking about this, I think probably you were talking about this, how can I make it run through a time? If I say from early morning to late at night for 7 days, just go through the traffic and...
Yeah, like in fact it will be the same thing as this, right. but instead of using the linear scale, you would use a time scale. And instead of parsing the data to an integer, you will parse it as a date.
Right.
So, and you can find plenty of examples of this online.
And it will automatically go through it and refresh the pages?
No. So that's only like to scale when you have time, but it depends on what you mean by automatic.
I think he means like it would be cool if in D3 you could show the buses moving around like a movie.
Right.
It's like you load the web page and all of a sudden you see like a movie of the 7 days go by compressed to 5 minutes.
You can do this. You would use you would use a request animation frame, or you would use a timer that would start on page load. But that's not even the best way to do, because you open the page and you have to be like it will run even if the user doesn't want to. So that's even better, I think, to have a slider, and you can have this slider playing starting automatically if you want. But yeah, it will always use a timer. But another timer that is better is called a request animation frame. That's the timer that D3 uses inside. Yeah.
So, and one way to think about that is that any slider, you can always say it starts from 0 and ends up at 1. Even if you're talking about big number, you can always scale a slider to any start and end number you want, right? But if you think about it in terms of 0 and 1, you can write your code so that you input a number between 0 and 1, and your animation is some fraction of the way. If it's halfway done, it's at 0.5. And so this is sort of like a technical way to think about it. If you start from 0 and 1, you can always scale to any other numbers. So you can scale from 0 to 1 to your min and max date. And as you slide your slider, and you get a value from your slider that's like 0.25, you can use a D3 timescale to say what is the date at that time, and then show the data from that date, right? Or show all the data that comes before that date. So yeah. Any other questions?
Let's get to work.
Yeah, let's get back to hacking.
Thank you so much.
Thanks, guys.
Thank you.